Hello, lovely viewers! Today we're diving into the world of Go programming to explore a fascinating topic: optimizing performance with a thread-safe object pool. If you're new to Go or just curious about making your code more efficient, you're in the right place. Let's get started. You know, when it comes to programming, sometimes it's all about efficiency. Picture this. You're dealing with a database connection, and creating them is not only time consuming but also resource intensive. What do? Well, that's where object pooling comes in handy. It's like having a pool of prepped objects ready for action. Imagine having an array of objects like connections and one special object in charge. This manager keeps track of which objects are in use and which are available. Think of it as the lifeguard of the object pool, making sure everything is well organized. Now, let's get practical and implement a simple connection pooling solution in Go. Our connections will have one basic attribute, an ID. It all starts with the necessary preparations. To make it thread safe, we'll use the mutex structure. You can think of mutex as a sort of lock that keeps things in order. We'll get back to that later. To keep things clean, we define a common interface. That is the DB connection interface. And here it is. It enforces rules for all the objects in our pool. In our case, it requires a getConnectionID method. Next, we write a simple object, concrete connection, which we'll put in our pool. It is a straightforward ID attribute and follows the rules by implementing the getConnectionID method. Now, the core of our object pooling pattern, the connection pool itself. This is where the real magic happens. It manages all the connections and ensures everything runs smoothly. Make this thing a bit smaller so we can see it all. We maintain two lists: idle connections for all the available connections and active connections for the connections which are actually used at the moment. We set a maximum capacity for our pool. An advanced version could dynamically adjust its size based on its use and demand, but for simplicity's sake we don't do that here. The pool lock attribute is a mutex. It acts as a gatekeeper, ensuring only one thread at one time can access the pool. Before we jump into action, we need to prepare our pool. We take an initial set of connections. If we have none, we can't create an empty pool, so we set up a ready-to-use pool structure in the initialize connection pool function. Now we come to another fun part. We want to get a connection from our pool. Here is how it works. First, have a look at the code. If you look at it, we first lock the door. That is the poollock.lock method. And then we promise to unlock it later, and that is the defer method, which is quite unique to Go. This statement is executed when the function exits, always. Next, we'll see if there are available connections. That means if there is an element in the idle connections array. If there is none, we return an error. If there is one, we grab the first one and chop off the first one from the idle connections. So the idle connection gets decremented by 1, the number of connections. And then we append it to the active connections to make sure that we keep track of the active connections. Then we print out what we returned or what we got, and then we return the result. To keep things clear for our lifeguard, we also need to return connections once we're done with them. That is the return connection method. And that looks like this. Again, we lock the mutex and we promise to unlock it. We also print out that we are trying to return a connection, and then we remove the connection from the active connections. I'll come back to that function later on, but for now let's assume that it exists. If that works out, we can append the removed connection to the idle connection because we can reuse it for another request. If it doesn't work out, we return an error. And if things run smoothly, we can return nil. Let's get back to remove from active method. That is this thing. Let's have a look. What does this do? Quite nifty, in fact. We first decide on our current length of our active connections, the number of active connections. Because this can change in the loop, we need to have a fixed number. If we find a connection, we swap our current connection, that is the connection we want to remove, with the last element of the array. That is the first line in the if statement. Then we chop off the last element. Actually, it's quite simple. That is the :.ActiveLength -1. And we return nil because everything went well. If we can't find the element, and it can happen, then we return an error saying we can't find the element. Now we can test. The main method is a bit more involved than usual. It's quite long, so we'll go through it. Let's go to the start of this. We create a pool with two connections, and then we get and return them. You see, we make a connection array with a make statement. We initialize the connection pool, and then we do the first connection, try to get it, and the second connection, and then the third connection, which should give an error because there are only connections available. Then we return the second connection, and we should be able to get the third connection. Let's try and see if this works. We're compiling. And yes, it works. We see the error when we try to get the third connection, we return the second connection, and then we get a third connection with the ID of 2. It works. So, to wrap it up, object pooling is a practical and relatively straightforward pattern. It's incredibly helpful for managing resources efficiently, especially when those resources are costly to create, like database connections or network connections. However, one challenge is making sure objects are returned to the pool. In future explorations, we might delve into mechanisms to handle that, but for now, you've got the basics of object pooling and Go all covered. Thank you for joining us today. If you enjoyed this vlog, don't forget to like, share and subscribe. And if you have any questions, leave them in the comments. See you in the next one.